All right, here we go. This is type 5, table questions. There is a review sheet in the fronts, little pointers, as well as some do's and don'ts. Okay, I'm going to first talk about the first AP problem in this packet, which is the 2007 number 3 AB. Now, even though it's AB, there are lots of topics in here that might be with BC as well. All right. In part A, you're given H as a composition of F and G minus 6. Now we know a little bit about both F and G from the stem of the problem. We know they are differentiable. And if they're differentiable, we also know that they're continuous. And so part A is asking us. Sorry about that echo. H of x we know is also continuous. All right, so back to part A. It's asking us about a value of r. So let's first find h of 1, which from the table we can find g of 1, which is 2, and then f of 2 is 9. So we get 9 minus 6 is 3. So now we know h of 1 is equal to 3. We've got to find h of 3 as well. So again, it's composition. We're using our table of values. We're finding g of 3. G of 3 is 4. And then we find f of 4, which we get negative 1. And so now we have h of 3 is negative 7. Remember, we have these theorems. So by the intermediate value theorem, we can say that since this h of 3 is less than your negative 5, which is less than h of 1, there must exist at least one. Now, question asks for one value, but there has to be at least one. It could be many. But at least one value of r for my interval between 1 and 3, right, such that h of r equals negative 5. This comes directly from the stem of the problem. Okay, so remember, not only is h continuous, but then you have to show a comparison between h of 1, h of 3, and then that r has got to be in between that interval of 1 and 3. All right, part B. Remember, we know that h of x as a composition of f and g is differentiable. And, of course, if it's differentiable, it's also continuous. And we know h of 3 minus h of 1 over 3 minus 1. Remember, that's just the slope of the secant line. And h of 3 and h of 1 come from part A. That equals negative 5. So we know by the mean value theorem that the slope of the secant line must equal the slope of the tangent line, which is the derivative. And there must be, by the mean value theorem, there must exist at least one value of c in our interval. And again, this comes right from the actual question. One value of c such that f prime, oops, it's going to be h, sorry, h prime of c has got to be equal to negative 5. That's the slope of the tangent line has got to be equal to the slope of the secant line. Okay, that's part B. Part C, we're given W, is the integration from 1 to g of x of f of t dt. And we're looking for that value of f prime of 3. Excuse me, w prime of 3. So let's find w prime. By FTC number 2, remember the derivative of an integral is just the function itself with that value plugged in. And now we're going to plug in 3. Don't forget the chain rule right here. Chain rule. Okay. And we get -2. That's w prime of 3. Those come from the table where we're given f and g. All right, part D. Part D is what I'm going to say, just a little bit tricky. So I'm going to draw you a little picture of a graph of the inverse of g and the graph of g. Remember, they're supposed to be symmetric about the line y equals x. Now remember, if I get a little point on g, the inverse of g, 2 comma b, then b comma 2 has to be on the original function. So if g of b equals 2, now I can go to my table and find the y value of g when the y value of g is 2, and that's when b is 1, or when the x is 1. So we know we have 1 comma 2 on g of x. So that means that 2 comma 1 is on my inverse. And we're asked for the tangent line. So the slope, we know from the table, the slope of g of x when x equals 1 is equal to positive 5. That's from the table. And then the inverse, or the slope of the inverse, oops, forgot the little one. When x equals 2 is going to be that reciprocal. All right, 1/5. So now we have the point, and we're going to put it in our point slope form. We've got the slope, we've got the point, which is right here. And then we have our slope, which is up here. Alrighty. All right, 2017 AB number 1. Part A asks you to use a left Riemann sum to find the volume. So, being visual, I'm going to draw a little picture of each of those points at their respective values of h, which is in feet, because this one does ask for units of measure. So make sure that you're going to use the correct unit of measure here. So here's my little very quick sketch of the values. I'm going to use a left Riemann sum. So just draw my little rectangles there at particular heights. And our volume here is going to be just the base, in this case 2 feet, times the height in square feet, and base times height, if base is feet and height is square feet, then we're going to get our volume in cubic feet. All right, that's part A. Part B, ask whether this approximation in part A is an over and underestimate. In the stem of the problem, it tells us that A is a continuous function that is also decreasing. so if we look at that continuous function that's also decreasing, then any left Riemann sum, I mean, you could just connect the points up there on the graph, any left Riemann sum is going to be an overestimate. And there's a little graph there that shows you. All right, part C gives us, again, an f of h, which is a function that models the volume of the cross-section. And we're going to integrate that. And again, we can use a calculator. And it's just 101.325 cubic feet. All right, part D happens to be a related rates problem. We know the change in height with respect to time is 0.26 feet per minute. That's given. We know the volume from part C is from 0 to some h of f of x dx. I want, or you want, the rate of change at which the rate at which the volume of water is changing. So we're going to take the derivative of both sides. So dv dt with respect to time, taking the derivative with respect to time. We're going to use ftc2. So we have f of h times the derivative of h with respect to time. When h is 5, we're going to have f of 5, and again, we're going to find that from the calculator, plugging it into that equation that was given in part C. dh dt was given as 0.26, and multiply that out. Again, it wants it in units of measure. We're going to get cubic feet per minute. Okay. 2017 AB number 6, no calculator on this problem. All right, we want to find the slope of the line tangent to the graph of f at my x value of pi. All right, we're given f in the stem of the problem. So I'm just going to write that again. This is a no calculator problem, so they're also, the AP readers are looking to see that you know how to take derivatives of trig as well as e to some value. So there's our derivative. Remember the chain rule. Used at least twice here. I'm going to put in pi wherever there is an x. Now on the AP exam, you do not need to simplify any further than this. You can leave it like that. The unfortunate part is later on in this problem, we're going to need to know what f prime of pi is. So eventually you're going to have to simplify it, but at least for this part A, you don't necessarily need to do it. Cosine of pi is -1. E to the sine of pi, where sine is pi 0, we get -1. Boom. All right, part B is asking us to find k prime of pi. So k is also defined as this composition of h and f. So I'm going to take that derivative of the composition. And again, the AP readers are looking to see if you can take the derivative of composition of functions. And again, remember, it's the derivative of the outside piece and then the derivative of the inside piece for chain rule. Now I'm going to put pi everywhere there's an x. Here is where you need that f prime of pi, which we found from up above is -1, or part A, and then h prime of f of pi, and f of pi you can just plug into the original function. Now h prime of 2 comes from the graph. So I've done a little chicken scratch over on the side. Okay, here is f of pi. And then here is from the graph, if you find the slope between the points 0, 0 and 3, negative 1, you get a slope of negative 1/3. And so that right there is what was put right there. Alrighty. Part C. Again, you're finding m prime of 2 given m as a product of two functions. And again, the AP readers are looking to see if you can find the product or use the product rule appropriately. So f prime of x is the first times with the second, which is pretty easy, just h prime of x, plus the second, h of x times the first, which again, derivative of the outside piece, and then chain rule derivative of the inside piece, which is another factor of negative 2. Now we're going to plug in 2 everywhere there's an x. Not too tricky. Be careful with the negatives. You could probably put this negative 2 right here out in front if that helped. All right. All my values of g are in the table. Remember, we found h prime of 2 in part B. Now, h of 2 is a little tricky. I'll talk about that in a moment. And then g again, g prime of negative 4 came from the table, and then that value negative 2. All right. So this is right here how you found h of 2. And then I'm just going to clean that up. And again, you can leave your answer in the red star on the AP exam. And again, so this right here above is, whoops, not g, sorry, h of 2 comes from the graph. All right, part D. This, after the previous problems, a couple of problems shouldn't have been as tricky as if you saw it right on the AP exam. All right, again, we know that g is differentiable. So, which means it's continuous. Every differentiable function is also continuous. I want to know, again, we have if g of negative 5 minus g of negative 3, so that's just change of y of a change in x, or slope of the secant line. Those values come from the table. And we get 8 over negative 2 or negative 4. Ah, lo and behold, that's the value we're looking for. So yes, by the intermediate value, mean value theorem, and then you can just copy the stem of the problem. There must exist, or must be, at least one c in the closed interval. Again, this comes from just right from part D, negative 5 to negative 3, such that our g prime of c equals negative 4, which again is the slope of the tangent line. And you can write that slope of the secant line's got an equal slope of the tangent. There we go.